watch television. Television, a picture made of light. A pattern of lines traced by electrons on the screen of the television picture tube. The picture tube consists mainly of an evacuated glass envelope. At the front is the screen, a transparent glass window. Its inner surface carries a layer of luminescent material which radiates light when bombarded with electrons. In the neck of the tube is an electron gun, projecting a thin beam of electrons. Wherever the electrons strike the luminescent material, light is produced. So that this tiny spot of light can build up a complete picture, deflection coils are placed around the neck of the tube, electromagnets whose magnetic field deflects the electron beam. Thus, the light spot is moved to and fro. And what we see now is the vital point in television. The light spot moves so quickly that the eye sees a continuous line of light. The deflection system does more than this. Not only does it deflect the light spot so quickly that the eye sees a line, but it also displaces the line downwards, producing line after line, one below the other, so fast that they merge, and the whole of the screen is evenly lit. Now, the picture. The signals from the transmitter control the brightness of the light spot. As the light spot is deflected, it forms a shaded line. And all these lines together create a complete picture, followed immediately by another and another, again and again, giving us movement, life, television. After this brief introduction, let us take a close look at what happens inside the picture tube. The first questions to arise are, what are electrons and how are they produced? Consider a good electrical conductor, for example, a piece of copper wire. Under a microscope, copper looks like this, and in an electron microscope, like this. Physically, it is not possible to obtain a greater magnification than this. But if it were possible to magnify copper 100 million times, we should see something like this. Copper atoms arranged in a regular pattern with electrons traveling between them. Electrons are very small, negatively charged particles which move at random, and now and again come into collision with the atoms. When a battery is connected across the copper wire, the electrons tend to move towards the positive pole. A current flows in the wire. Where the wire is constricted, the current is denser and the collisions are intensified. The wire begins to glow. This is important. We are interested here not in the light given off, but in the high temperature developed. Due to the heat, electrons splash out of the wire. This is known as thermionic emission of electrons. The electrons released in this way are used to give us our television picture. However, very large quantities of electrons are needed, far more than can be emitted by a single filament. Consequently, a cathode is used, a little cylinder sprayed with a material which emits electrons copiously. When the cathode is heated, a cloud of electrons forms around it. This is the beginning of the electronic process in the picture tube. The evacuated envelope of the picture tube contains not only the cathode, but also another electrode, the anode. The anode is made positive with respect to the cathode, so that the negatively charged electrons are attracted by the anode. From the anode, they flow to the battery, which in turn propels them to the cathode, from which they are emitted again. Thus, there is a continuous current of electrons, even though part of the circuit is a vacuum. We will show the situation diagrammatically. The cathode is on the left. Green symbolizes its negative charge, and the anode is on the right. Its positive charge, shown in red, gives the electron such an acceleration towards the anode that if the anode contains a small aperture, some of the electrons will shoot right through it. This is called an electron gun. The beam diverges because of the positive charge on the anode. The electrons which shoot through the center of the aperture travel on in the same straight line. But electrons nearer the edge of the aperture are attracted by the positive charge and are deflected. The target of the electron beam is the screen of the picture tube, the luminescent layer which radiates light wherever it is struck by electrons. This layer is backed up by a very thin layer of metal which serves as a reflector and increases the brightness of the picture. Electrons pass through the metal layer easily, but collide with and are held in the luminescent layer, from which they must be removed. Otherwise it will become negatively charged and so repel other electrons. The metal layer is connected to the positive side of the battery just like the anode, so that all the electrons can pass back to the battery through either path. But this hazy, diffused spot of light can never make a good television picture. It needs to be a sharp point of light which can be varied in brightness. This brightness is determined by the number of electrons striking the screen. So to alter the brightness of the light, we must alter the intensity of the stream of electrons. This, in fact, is done with the help of the Weynoldt cylinder. Its negative charge repels the electrons, causing the beam to become narrower and the light less bright. Any variation in the charge on the Weynoldt cylinder varies the number of electrons, and hence the quantity of light. At the same time, however, the sharpness of the light spot is affected because the charge on the Weynoldt cylinder also alters the paths of the electrons. To overcome this, The electron gun is fitted with two more cylinders, one with a negative charge and one with a positive charge. If now the voltage on the Waynoldt cylinder is varied, the brightness of the light spot is varied, but not its sharpness. The light spot remains focused to a sharp point. Now we will look at the actual shape of the electron gun. The various electrodes that so far we have seen only in diagrammatic form are cylindrical in shape. Here is the cathode, here is the Waynoldt cylinder, the anode, the focusing electrodes. When these electrodes are connected to the appropriate voltages, the gun produces an electron beam. The electron gun is equipped with connecting pins and other assembly details, and mounted in the neck of the picture tube. As we have seen, the rapid horizontal and vertical displacements of the light spot, which create the complete picture, are affected by the deflection coils around the neck of the tube. The action of these coils can be explained as follows. Consider two electromagnets, iron cores wound with copper wire. When a direct current flows through the windings, a magnetic field is created. Reverse the current, and the field also reverses. As we know, a magnetic field exerts force on a conductor, for example, on a copper wire through which current is flowing. The conductor is given a sideways motion. The direction of motion reverses when the field is reversed. A beam of electrons is deflected by the field in the same way. It moves sideways, but much more quickly than the copper wire. Now, instead of passing direct current through the electromagnets, we will apply an alternating current and produce a field which gradually increases and decreases, first in one direction and then in the other. Slowly, or if required, fast. The electron beam will be deflected in a similar manner. This is what happens in the picture tube. We are looking at the inner side of the screen. When the beam is deflected in the horizontal plane, this is known as horizontal deflection. If the coils are turned through 90 degrees, they will give vertical deflection. In a television receiver, both coils are used. Furthermore, a special kind of alternating current flows through them, which is known as a sawtooth current. The meter shows that a sawtooth current first grows steadily and then suddenly reverses. The electron beam moves in a similar way, a gradual deflection and a sudden return. Thus, the horizontal deflection coils cause lines to be traced in very rapid succession. The vertical deflection coils move the beam from top to bottom at a much slower rate. Now both sets of deflection coils are working together. A deflection system such as this, with separate electromagnets, does work, but better results are obtained with a ring-shaped core. This is made of a ceramic magnetic material called ferrox cube. These coils control the vertical deflection and a second set, the horizontal deflection. The complete deflection unit is wound in this way so that it fits snugly around the neck of the tube. The deflection system is now complete, and the tube can be switched on. As we have seen, the quantity of electrons from the electron gun is regulated by the voltage on the Waynoldt cylinder. So, if the signal voltages arriving from the television transmitter are applied to the Waynoldt cylinder, the electron beam behaves accordingly. The brightness of the light spot varies, and on the screen appears the television picture.